Yes, it's coming. Yeah.
Okay. So today I am going to talk about two image handling libraries. One is OpenCV and another is Keras. So OpenCV stands for Open Source Computer Vision Library. So OpenCV is a open source library which is used mainly for computer vision, machine learning, and image processing tasks. And using this, we can identify different objects, faces, and even handwriting of human from different videos or images. And also, it can be integrated with various libraries such as NumPy, which I have discussed in previous lab. And also, it has C and C++, Java, Python interfaces. Interfaces means we can write C, C++, Java, Python code to interact with OpenCV code. So next the question is, why is OpenCV is efficient? Because as we have discussed in previous class that the NumPy was also efficient because it was written in C and C++. And likewise, OpenCV is also written in C and C++ to take advantage of multi-core processing. And I will discuss a little bit about multi-core processing in coming examples. And also, OpenCV features GPU acceleration for real-time operations. For example, self-driving cars and robotics. So, if you see OpenCV history, OpenCV first invented by Intel for CPU tasks, but recently they have transformed it from to CPU to GPU, and now we can also use for both CPU and GPU. So, for example, as I discussed earlier, that image is nothing but a matrix. So let's suppose A is a matrix and B is a matrix. So now, and it is also important to note that any image transformation is nothing but a image multiplication or multiplication of two matrices. For example, if I take a image which is denoted by A here, and I want to transform it from another one space to another space, then we have to multiply it with another matrix which is called B. So now, how this operation takes place in CPU and GPU? So you can see from this picture that in CPU you can see that maximum in CPU 4 to 8 cores are there for CPU, but in GPU there can be hundreds and thousands of cores. For example, if you see this diagram, you can see that in orange there is a cache memory, and in yellow here is a control. So you can think of this yellow part as a core, and this orange part as a cache. So you can and for GPU we can see that there are several cores like that. And it is also important to note that for each core there is a orange color cache. So what happened, suppose you want to multiply two matrices, one is A and another is B. So in case of CPU, whole array will be residing here and B will be residing in cache. So during multiplication it will take much time, much more time than GPU, because in case of GPU, what you can do is you can store each and every row in separate in different cores. For example, you can store A1 here, A2 here, A3 here, and like that A1 here. And for each core, B will be residing in this cache. So this multiplication will be simultaneously. That is why GPU acceleration is important in case of OpenCV, because in real world the image sizes can be very large, and for self-driving cars and robotics it is real-time operations. It means that in the time of driving the cars we have to recognize the images correctly, otherwise there can be any accident. And so yes, and one more thing, and the size of all caches in GPU is called VRAM. So if you, and GPU is nothing but a graphics card which we often use for gaming purpose. So that is the difference between CPU and GPU, and OpenCV works both for CPU and GPU. Next is to install OpenCV. You just run conda install -c anaconda OpenCV, and here is OpenCV source code. And like NumPy also, in OpenCV also there are several classes, and each class consists of attributes or methods or function. For example, if I want to read or display or convert a image to a grayscale image, and as I said, in OpenCV classes there are several methods or function. For example, for reading there is a function called cv2.imread. For showing purpose it is called cv2.imshow, and third is cv2 for .imwrite, and cv2 is OpenCV version 2. So you can use any of those function for different tasks, and each function will take two arguments. First one is directory of the image, it means where the image is residing in your machine, and second one is for which purpose you want to read it, or it is called flag, or the way image should be read. For example, uh, for um, for example, first we have to import it, like numpy import cv2, and then for plotting the image you have to call matplotlib dot pyplot as plot. So to load color image, and to show the actual image, you have to call imread. Then first, as I have told, that it is the image directory, and it is cr7.jpg, because in this same directory where my this Python notebook is there, cr7.jpg is there. That is why it is only cr7.jpg. Otherwise, we have to give the full directory in which the image is residing. And next is cv2.imread underscore color, and it means that it will show the color image, in which transparency of the image will be neglected, and it is the by default flag. So, and another one is for imread.color you can also use 1. So there are three flags: one is 1, another is 0, and another is -1. And 0 is used to show the image in grayscale version, and -1 is, I will discuss it later.
So
So
what other options do we have?
sorry, what are
I
the?
mean, what other options do we have in the second argument?
Yes,
Like
in second arguments there are only three. So first one is imread underscore color, and second one is imread underscore grayscale, and third one is color dot rgb to gray. Okay, and in place of that you can also write -1 here, and 0 here, and 1 here. So is it clear?
yes, sir.
Okay, so if you show it plot dot imshow and image, and it will show the original image, and you can just carefully see this scaling here. For x-axis it is to up to 700, and y-axis it is up to 400. And as I said, if you want to see this image in grayscale version, you just all are the same, you just put the second argument here as imread underscore grayscale or 0, and then as well as before, you just show plot.imshow image, then it will show the grayscale image. And another point is there, you can see that the image is not 100% black and white, and this function is implementation dependent. And because I am using Linux OS, and so that is why maybe this image is not 100% grayscale. So what I have done is, and there are another method to convert a image to a grayscale, which is written here. So for that, you have to write cv2. First you have to read this image as cv2.imread cr7.jpg, then you have to call this cvt color function. Within that there is a argument called cv2.color rgb to gray. And what this cvt color does, this cvt color converts an input image from one color space to another. So here you can see that the image is fully grayscale. And next for imread, the last argument, which is cv2.imread underscore unchanged. And if you see the image, and it what it is doing, it is load the image as such including alpha channel. But here is a point: in jpg image there is no alpha channel or transparency, but in png there will be a transparency. So you can't differentiate this picture with this picture. Both in this case both are same, but if you use png or other format image, then you can see that this output may be same, may be different. And likewise there are several conversion space conversion using OpenCV. And for example, it is mentioned here, and you can also go through this link for several other conversions. And next is geometric transformations of images. And I already have discussed transformations means taking an image from one space and transform it to a different space. And space means, suppose a image is in 5 dimension or 6 dimension and you want to transform it into third or second dimension. So what we have to do is first take the image, then build a transformation matrix M, and then multiply this original image with this transformation matrix. And these transformations are several types. One is scaling. Scaling, as we all know, scaling means the size of the image will be reduced, or zooming purpose, resizing the image. So scaling is just resizing of the image. So first we have to to resize, first we have to fetch the height and width of the image. That is why the first line is doing height comma width equal to image dot shape and colon 2. Why it is colon 2? Because image dot shape returns three value: one is width, height and channel. And scaling purpose only two are needed: one is width and height. That is why here two is needed, two is written. And then to resize it, to resize, what I have done is we have just um, multiplied by 2 into width and 2 into height. And so this resize function takes three arguments. First one is the original image, and then the scaling. You can half into width and half into, you can shrink the image or you can zoom the image. So where here we have zoomed the image, so 2 into width and 2 into height, then interpolation equal to cv2 dot inter underscore cubic. And here also there are several types of arguments. For example, inter underscore cubic will do the slowing purpose of an image. If I write cv2 dot inter underscore area, then it will shrink the image. And if I write inter underscore linear, it will be for zooming. So if I plot this image, you can see that here the x-axis was up to 700 and y-axis up to 400, and here it is getting doubled, 1400 and it is 800. So it is called scaling. And second one is rotation. For rotation purpose, rotation of an image in a certain angle. So for transformation, as I have said, first you have to take the image, then you have to form a transformation matrix, then you have to multiply the image with the transformation matrix. So here also first we have taken the rows and columns or width and height, then we have created the transformation matrix M. So and this transformation matrix will be of your choice. You can do any transformation matrix, and angle also it is your choice. So first m equal to cp2 dot get rotation matrix 2d. It is a function which is included in cp2, and then you just put your arguments of your choice. First one is columns by 2 and rows by 2. It will be the center of the new image. Second one is the angle of the image, in which direction you have to rotate the image, and second one is the scale. And after that, it is the formation of transformation matrix. Then you have to multiply the original image with m. For that, you have to call this wrap affine function. So affine function will do is, it will take the original image, then it will multiply with m and return the columns and rows. And if I plot it, you can see that the original image is rotated. Next is translation, and translation is the shifting of the object location. So you can see from the image that the image is shifted, and for that it is same as other. The method is same. My means, first we have to create the transformation matrix, then you have to call the wrap affine to multiply the original image with the m. So first you just take the rows and columns, then m equal to, it is the formation of transformation matrix, and this 150 is the direction in which you have to translate it, or you have to shift it. So here you can see that the 150 can be written as t underscore x and t underscore y. So in this direction we want to translate it, and then you just take the image and the transformation matrix, multiply it and plot it, and you will see that the image is shifted. Sorry.
Sir,
Yes.
hello.
Yes.
Basically, an image is a matrix of an image is a matrix of number 0 to 255.
Yes.
Is it
Yes.
okay?
Yes. Yes.
So if it is number like 0 to 255 is depicting the color of the image,
Yes.
basically the
Yes. Pixel values. Yes.
colors. Oh, yes, sir.
Hmm.
Pixel value. So then how, sir, I got that part. They are responsible for the color changing, like they are responsible for changing color into grayscale or any color. But
Yes.
how the pixel value can change the can transform the image, like it can, how it can rotate the image or how it can shift the image. Like basically these are the pixel values now. So how they are able to change the degree, like angle of the image, or how it basically rotate or translate the images, how they are able to.
So actually the original image pixel are fixed, which is 0 to 55, and if you see the transformation of any kind of matrix, you have to first create a separate matrix, and I have done nothing with the original matrix, which is the in which the pixel values are 0 to 55, and this m is new matrix, and you can put any type of values here. It is of your choice, and in here also, rotation matrix, the original image is as it is there, and the pixel values are 0 to 55, 0 to 255, and you just creating a new transformation matrix, and this matrix will say that how you transform the original matrix.
So
Am I?
that's what I am asking. Like what if, like if I am multiplying a different, like I am creating a matrix M for translating the my image, translating my previous image. Then
Yes.
I created a matrix, and then when I use the what of I'm function,
Yes.
then matrix will be multiplied by the my previous image matrix.
Yes.
So
Yes.
then what if the value go beyond 255? Like
Actually, I think so that wrap affine function, and this function is written, the function definition in OpenCV is written such a way that I think it will be transformed, the new image, in which also the image pixel values will be same as the original image.
okay.
Actually, you are just rotating from one space to another space. Means dimension will be changed, but the pixel values, I think, that has nothing to do with pixel values. For example, suppose if I say, if you know if you know if you dimensionality reduction, if you can hear that, that in which we do, what we do is, we do a highly for example, if there is a 50 dimensional image, we just transform to a 3-dimensional image. And in where we have done is, we just take the topmost features or topmost eigen values to reduce the dimension, and that way you can think of it. And here also, this image, one space is transformed to another space, and how this and which features and which dimension will be retained, for that you have to go this wrap affine function, I think. Am I
Shubhankar, shall I say something?
okay?
Sir, I think that the pixel coordinates are affected and the pixel values itself are not affected. So,
Yes, yes, yes. Pixel.
so, so if we are trying to move it somehow, then a matrix, some new matrix will be generated, and when we multiply it with the pixel coordinates, then the corresponding change might happen. For example, if we want to rotate by some angle, or if we want to move by some, say, some centimeter or whatever, the pixel coordinates are affected and the pixel value is not affected.
Yes, yes, yes. I also think so, because as I said, that pixel values will be same, as I have nothing to do with pixel values. Image is there. I just building or creating a new transformation matrix, and this transformation matrix will say the original image, that which direction we have to rotate it, if I rotating it, or which direction we have to shift it. This is the thing which transformation matrix is doing. But
Yeah. So here the transformation like can be of two type. One can like change the pixel value will be always in the range of 0 to 255. So like if I am changing intensity of the image, so you want to make some portion of the image brighter or darker, in that case that pixel value will get changed. So that is one kind of transformation. But when we are talking about this rotation or that other operation, there, as another student was mentioning, that you are changing that coordinate that time. Okay. So both kind of transformation can happen. So that is the thing. But the value will range between 0 and 255 only.
Okay.
so can I move forward?
Yes, sir.
Okay. So now, why do we need thresholding? And sometimes in image processing, we need to separate an image into some regions, and which is called, in image processing, which is termed as segmentation. And segmentation is a natural way to segment such regions in thresholding, and which is very much important in case of object detection, traffic control systems, or medical imaging. And there are several types of thresholding. One is simple thresholding, and in simple thresholding, what we have done is, for each and every pixel, the same threshold value is applied, and if the pixel value is smaller than the threshold, it will be set it to 0, and if it is greater than the threshold, then it will be assigned to the maximum value. And as for thresholding, there is a function in cv, that cv dot threshold, and it takes 4 arguments. First one is the grayscale image, then the threshold value to classify the pixel values, then maximum value of the threshold, and next is the thresholding types. For example, uh, first we have converted the original image into the grayscale, that is why it is written as 0. And then we have called this cv.threshold function, and this cv.threshold function will return two things. One is threshold, new threshold image, and another is rate, which is the threshold value used. And as I have told, that it takes 4 arguments. First one is the grayscale image, and second one is the, you can think of it as a minimum value of threshold, it is a maximum value, and the types of thresholding. And for simple thresholding there are several types of functions. For example, there is a this one, then binary inversion, trunk 2020 inversion, and for each and every type there are several formulas are used. And for that, for if you want to see the formulas, then you have to go this you have to go to this link. And for example, so we have taken the original image, then it is the minimum threshold, maximum threshold, and third one is the thresholding types. And for here we have used I think 5 types of simple thresholding, and we have plotted it. So you can see that original image is here, and then binary, and it is a type of simple thresholding, and likewise there are 4 types of 5 types of simple thresholding types. And I think the code is here. So first we have called the 5 for 5 times we have to call this 5 cv dot threshold. Then titles means the original image, binary inversion, trunk 20 and 20 inversion. And for images, uh, first we have plotted the original image, that is why the image. Then second, then this thresholded image, and likewise this fifth. And we have taken this for loop to just subplot it in this manner. So what it will do is plot dot subplot 2 3. 2 3 means there will be 2 rows and 3 columns, and I plus 1. So it will start from 0, then 0 plus 1, 1 plus 1, likewise it will plot it. And next is adaptive thresholding. So here in simple thresholding we have seen that we have just apply the same thresholding in all the places, but in real time, in real pictures, we can see that the if an image has different lighting conditions in different areas, and it is the most likely situation. So then we have to adaptively determine the threshold for a pixel based on small region around it. So it means you have to first take a region of the image, then you have to apply the threshold. And for that there are 2 types of adaptive thresholding. One is the adaptive underscore threshold mean C, and another one is adaptive underscore thresholding Gaussian C. So here for that, for first one, the threshold value will be the mean of the neighborhood area minus C, and C is a constant value. And for that, the thresholding value will be Gaussian weighted sum of neighborhood values minus C. And if you see the code, and it is like the before the previous one. So first we have to call this threshold. It is first one is for plotting the original image, and the second one, which is threshold 2 and threshold 3, is for these 2 types. So and here also you can see that first image is taken, and the function where it is called adaptive threshold, and this cv dot adaptive threshold for adaptive thresholding, and here it is just cv dot threshold for simple thresholding. And here you can see that there are few arguments. First one is the grayscale image, then the maximum thresholding values, and then the type of thresholding, and the and 11 and 2, it is the size of the neighborhood area. You means it is the size of the neighborhood means the 11 by 2 2 matrix. You have to first you have to calculate the mean, and then you have to minus C. So it is for the first one. And for adaptive underscore thresh, then underscore Gaussian underscore C. So it was for that. And the rest is the same. Titles, then images, here 4 images, and here you are just subplotting 2 rows 2 columns, that is why 2 2 I plus 1, and rest is the same. And
Sir,
next,
what is C?
sorry,
What is C here? Like we are
C,
calculating the
yes,
value, no?
yes, C is the constant value. C is a constant value. If you just um, call this function, C will be automatically given by OpenCV. You don't have to do anything. And if you go in this link I have mentioned, that it will C is a constant, and it can be negative or 0 or minus.
Okay, sir. Sir, is thresholding only done for grayscale images?
No, for thresholding, first we have to, if you have any type of image, you just convert it for grayscale, and then you have to use this function. For example,
Okay.
my original CR7 image is not grayscale. It is just a original RGB image, you can say, and just we have converted it to grayscale, and then you have to call this function. You take any image, you just convert it to grayscale, and then this image argument will be grayscale image. And here we didn't I didn't have done this because, or here it is done already, have done img equal to cv.imread cr7.jpg comma 0. So this image is here converted to grayscale, and this image I have taken here and here also.
Okay.
Is it clear?
Yes.
Okay. Then so to improve contrast of histogram equalization, so and OpenCV there are hundreds of functions like that. So if you want to increase the contrast, you have to first convert it to a grayscale image, then you have to call cv2 dot equalize hist, and then the grayscale image. And what it will do is it will do the equalizing the pixel values to improve the contrast. And now I just hstack, call the hstack, which is a np and numpy, which is residing in numpy package. And hstack means horizontal stacking. So I have this original image and this the improved contrast image I have just stacked together, so it is now a single image. And for edge detection, there is a call there is a function in cv2 which is called canny. Canny is the, I think, the founder's name. And if you first you have to, for each and every operation, first you have to convert it to a grayscale image, and then you have to call this canny function, and you have to pass this image and the minimum threshold and maximum threshold. I think it is maximum threshold and it is minimum threshold, and then you have to plot it. So I have plotted it here. You can see that it is original image and it is the edge of this original image. So it is now this is the OpenCV part. And now what I have done is I have included a little bit of Keras. And nowadays the image classification is done using Keras. And as an introduction, Keras is an open source software library that provides a Python interface for artificial neural networks. And Keras acts as an interface for the TensorFlow libraries. And why Keras is easy, why Keras is used widely, because it is easy to read and write. You can also use TensorFlow, but Keras is easy to read and write. That is why Keras is used. And often for research purpose, TensorFlow is used, and for application purpose, if you want to design your own product, then Keras is used. And if you see this structure, you can see here that the backend is for Keras API. Backend can be TensorFlow or Theano or CNTK. And if you write a Keras code, Keras have several API, which is called application programming interface, and it will and this API will talk to TensorFlow, and this Keras code will be converted to TensorFlow, and then it will be executed. So that is why the backend is TensorFlow. And low level libraries CUDA, as I have shown in first in this first one, that there is a GPU and there are multi cores. Each cores have their cores and cache. So you can customize this codes using a programming language environment which is called CUDA. And in this last low layer, there is GPU and CPU. So it is very actually this picture is very important to know how the things are placed. So if you import any Keras library, you can see that it is showing that using TensorFlow backend, and that's the reason. So Keras is an API which will talk to TensorFlow. It will convert the code you write in Keras into TensorFlow, and then it will execute it. So for example, if I want to classify a image, for example, I have taken here the MNIST data, and MNIST data contains the handwritten digits from 0 to 9. So first we have to import those Keras dot models sequential dense dropout. I will discuss it, and each one of them is layers API. So it is nothing but a API. If you call them and use it in your code, then what we will do is it will talk to TensorFlow, and TensorFlow will execute the rest of the execution part. So first we have to load the image, and MNIST is there in Keras. So just to call from keras.dataset import MNIST. This is the image dataset, and then you can load the image as train and test. So xtrain, ytrain, xtest, ytest, and then first we have to pre-processing and image augmentation. So before designing or before building any artificial deep learning model, you have to first pre-processing the data, which is done to efficient training purpose or to speed up the training, and to make our model flexible enough so that it can work for any images. So first we have taken the extend data set and we have divided by 255. It means that the images, the maximum pixel value is 255. If you divide it by 255, the all image pixel will be lie between 0 to 1. That is why this steps it is done, and it is done to speed up the training purpose. It will take less time to less time to train the model. And then it is image augmentation. Image augmentation, you can see that here image shifting is there, rescaling is there, zooming is there, horizontal flip is there, and these steps are done because to make your model flexible enough so that it can work, because in real time the image will be not like the ideal image like 5 6. It can I can write 5 or 6 in any manners. That is why you have to augment the this type of uh, this type of augmentation to make your model flexible so that it works very good in different scenarios. And then you just create your neural network architecture. First you have to model you have to define your model, which is sequential, and sequential is nothing but there actually in if you see the artificial neural network, there will be several layers and linear stack of layers, which is called sequential here. And then model dot add, and Keras is that much easy. You just write model dot add this and it will add this layer for you. And then model dot add activation relu, it is an activation function. And then I have also discussed in previous class that flattening is used for imaging, so that the image is flat, image is converted into 1D array to fit in RAM. That is why this step is here, flatten. And then and what this activation function is done is actually in neural network there are several neurons, and what will be the output of the neuron, it will be decided by the this activation function. And there can be, then there are several activation functions like relu, sigmoid function, tanh function. And nowadays relu is most widely used because it is easier to train the model without any without any drawbacks. So first we have defined the sequential model, then we have used the conv-td, which is used for convolution purpose, and here you can see that we have used the 3 by 3 filter, and for 32 3 by 3 filters. And convolution is nothing but it will take the original image and it will filter it. Filter means it will just multiply pixel by pixel and it will create a different image, that is convolution. And where, and you can say that why 32 such uh, filter is taken. So the reason is because to in an image there are several features. For example, there are edges, there are borders, there are several types of features in image. So to capture all features you have to take a large number of filters, that is why it is 32. Then the activation function relu, then you have to flatten the image, then you have to and this order you can design on your own, and you have to see which one give the best accuracy. So it is nothing that this is the only order, so I have written in this way. Then dense, then activation function, and dropout is used to prevent from overfitting. So what in real world, what if there are several layers and the original neural network is very large and the data is less, then there is a problem called overfitting. And if I say in simple word, in overfitting, training error will be less but test error will be high. So for example, if I train and then it is showing that the error is 1% and test error is for example 20%, then it is called overfitting. And so overfitting, to prevent it, there is a if you can add this layer, and you can think each of one as the layer in a network. So dropout is a layer, and 0.2, and 0.2, what is 0.2? So what dropout done is, it just kill randomly, it just pick some neurons randomly and it will kill them, because overfitting is overfitting is taking place because of large number of larger size of the network and small amount of data. So it what it will done is, it will do is, it will take some random neurons and it will kill it. And the taking and the rate of taking will be 0.2. So if there are 10 neurons in first layer, then it will take 2 neurons and it will kill it likewise. And then it is a batch normalization layer. And why it is used? Because first we have seen that with this each pixel is first normalized or divided by 255 to scale it from 0 to 1. But if there are several this type of layers, after some layers the value can be actually the distribution of the input can be changed. The distribution, if you plot it, then the value will lie from 0 to 1. But if there are several layers in the neural network, then the distribution of the image, if you plot it, you will see that the distribution can be changed. So again, the recentering and rescaling of the pixel, you have to use this batch normalization. And then dense, and then activation. And activation is softmax. And softmax, what it will give the probability value. Means I have told that the data set which we have used is MNIST data, which consists of 0 to 9 handwritten 0 to 9 digits. So it will give that this image, the percentage of the image is to belong from 0 is 2%, to belong is 3%. If this image is originally belong to 7%, it will give as 0.8 0.9 probability. So that is why softmax is used. And then you can train the model for certain number of epochs, and we can specify the number of epochs, and this is a optimizer. And here also there are several optimizer, and nowadays it is highly used as Adam. And you have to compile it, and you can print the model summary, and at last you have to call model.fit to train the model, and you just fit your training data, validation data, and the epochs, and you will see that the accuracy for each epoch. You can run it, and so that's it from my side.
Oh.
Thank you.
Sir, hello.
Yes.
Sir, can you please explain the con2d function?
Okay.
The second line.
Yes. So con2d, for example, if you what in CNN convolution neural network, what is done is to detect the edges, or to detect the um, any border or any features of image, the convolution layer is used. So for example, and for convolution, what the and I have said that for each image there is a pixel value from 0 to 255, and this image will be taken, and this convolution layer will be, what it will do is it will take the filter size is 3 and 3, and it is also a matrix, 3 by 3 matrix, and 32 such matrix will be there, and each sorry.
Are different? Like all these 32 filters are different or same? Like
So
their matrix values are same or different?
you can
For all
no, you can specify your actually I have just taken one con 2D, and you can what in real time what it has done is you can copy it, you can paste it, and you can change the size of it like that. And it is better to use several sizes of convolution, conv layer, filter size, several size and several numbers of filter. That is how it will be good to extract the features of the model, and your model will be very good. And it is also a drawback if you use several this type of layers, then there is a problem which is called overfitting. So and these things are actually your experience will coming to picture, and it will depend on the size of the data set, and which types of images are there, and then you have to decide on your own. So how many convolution layer you will use, how many filters you will use, or how or what will be the size of the each filter, and that is your choice, and it will give different for different types.
So like if we are assigning like 32 filters we are using, like we have written on 32 in the con2d function.
Yes.
Like if we are assigning, if we are making 32 filters for the convolutional layer, then
Yes.
sir, these 32 layers have these 32 filters. Basically, these filters are matrix, 3 by 3 matrix.
Yes.
So all these matrices are different or they are same. Like one is used for filter, like one is used for edge detection, one is used for border detection. Then these all 32 filters are different.
Hello.
Yes.
Suvankar, shall I say something?
Yes.
Uh, yeah, maybe I don't know. It will be discussed later on, maybe going into advanced. But these filters are basically learned by the system. You are not going to define. So the values and whatever the filter values, you said 3 by 3. So those values will be learned by the algorithm itself, and that algorithm will decide. You cannot say for certain that what feature it has learned. Okay, it may be detecting age or maybe some color related feature, but that is the advantage in neural network, there you don't have to define by yourself anything. So all those filters can be different, and it will be learned based on the training process.
Okay.
You are not going to define it.
I think I want to add few more things, Sujoy. So I think to answer your question, So thing is, when you write this line con 2D 32 3 cross 3, essentially what you are doing, you are basically taking 32 filters of each of size 3 cross 3. Okay. So I'm not sure whether you have any background in convolutional neural networks, CNN. So when you learn CNN, you will get to know how things are done. But just to give you a quick answer to your question, is that when you write this statement, so at least for this case, all the matrices that you take, 32 matrices 3 cross 3, is basically same. Okay, so they will have same value. So there's a technique called parameter sharing in CNN, and it comes from there. So now you can basically add multiple such things. So when the moment you add multiple such lines, so for maybe you can add something like, you can take say another 30 filters of say size 4 cross 4 and so on. So they will be different. Okay, and each filter is going to play one particular role. So maybe, I mean, it is not very clear which filter is going to do what, whether age, whether color, whether shape or something like that. That is difficult to interpret often, but they will basically serve different purpose. But for this line, if you say con 2D 32 3 cross 3, all the matrices will have the same values.
Sir,
Okay.
what is the actual meaning of overfitting in these neural networks? Like if we are using convolutional neural network, what is this overfitting?
So yeah, basically the meaning is same in any machine learning. So like, see, neural network is nothing but a heavily parameterized model, right? You have too many parameters which you learn from the data. Now the problem is, in any case, in any machine learning algorithm, so when you have little bit of data, training data, and you end up taking a model with so many parameters, but the number of parameters are typically much higher than the number of examples that you have in the training set, then what happens is that you can simply remember all this training data using your too many parameters. So you do not learn anything. You do not learn any pattern in the data. So you simply can remember. You can store the things, the original data, training data into your parameters. And that is typically called overfitting. Okay, the moment you see a new example, your model, because your model didn't learn anything, so it will give you very wrong results. So it is essentially the same idea that I talked about in one of these lectures, like in machine learning.